This is our lab number 2. Here we will use Mathscript in Labview to generate the time domain signals. This is the pre-lab in which you had to write this code in MATLAB editor script, and then you will run it, and then you will plot this signal. So this is sync function. So the equation for sync function is sine of x divided by x for all the values which are not equal to 0, and it is equals to 1. You see the amplitude is 1 for x equals to 0. At 0 the amplitude is 1. So we will write the same code but in Labview. Okay, in Labview, if you see here, you go to diagram view. So here you go to program flow, and then you take Mathscript node. So Mathscript node is like this, and then after that you will write your code here. For example, x equals to 0, and then step equals to 0.01, like this. And and for example, if I want to write x or y equals to amplitude a into sine of 2 into omega into t, then omega equals to 2 pi f. So then you right click here, and then you create input. Okay, so this will be your input. Let's say what we need here, we need omega equals to w, and then from here you will write. This is now input is complete. Okay, if you want to take another input, for example, a is an input, you will create input, and then you will rename it, and then you will create from here a. Okay, now after that you will create here output. So output is what? Y and t. So we have to define t here also. So t equals to 0, 0.01, then 2, okay, 1, then so then it will be output 1 will be t, and so output 2 will be y. Then after that you will go to program data types, and then after that you will go to cluster and build cluster. What this cluster will do, it will combine these two variables, and then you will go to panel view. So you remember you have to take graph always from panel, and whatever is the variables here, you will bring them here. So let's see. So actually it should be pi also. Okay. And then, okay, so you will take graph from here and then put it here. So this is simple. So let's run it here. So if you take variable 40 and in its amplitude 1, so you see this kind of waveform is plotted. So this is the method to write any code in using Mathscript in Labview, and then generating the signal out of it. Okay, so first let's go to question number 1. So if you see here, so sine wave generation using Mathscript. So we have delta, which is 1 over fs. Fs is the sampling frequency. Then the start value is 0. Step is delta t. Step is the gap between the two signals. Then stop, the stop value. For example, if you see here, let's see the same one. So you see this is the total. So this is start value, this is stop value, and then this is the step 0.01, 0.02. So these are the steps. Okay, so then start with so t, the time scale is start, then step, and then stop, and then this is the equation 2 pi f into t sine of 2 pi f into t into a is the amplitude. Now you can see from here that t and x is the output. Okay. Now what are the variables we have to define? So this is a variable, this we define input. Then after that, this n is the input, then amplitude a is the input, and also f is the input. So if you go here, you will provide sampling frequency, let's say 1000, and number of samples, let's say 1000, and amplitude equals to 2. I will provide you these values 10. So if we run it, so you see, this is a sinusoidal function we have plotted using Mathscript. Okay. Then in question number 2, we have generated a sine cardinal function. This is a sinc function using the equation. You remember that the equation for the sinc is sine of x divided by x. Okay. So sine of x pi n delta t into t, sine of n t, n into t divided by n into t. Okay. Divided by pi t or pi n t. So then a is the amplitude. Okay, we can write a here also, it will be the same thing. We write a here and remove this, it will be the same thing. So then we take the inputs fs, and then start value starts from minus n by 2. So n is the samples divided by 2. Then because it will start from minus, because the sinc is distributed from minus to positive axis. So, and then here build cluster and then graph. If you go to here, so let's say our sampling frequency 1000, frequency equals to 10, and amplitude, let's say we say 1, and then samples equals to 1000. So you will see that it will start from 1000 because samples n is 1000, so divided by 2. It is divided by 2. So you see, it is sinc function starting from minus 500 to 500, and at 0 it has 1 amplitude. Okay. So this is it about question number 2. Then question number 3, we generated a sine wave using Mathscript. So here we used values, start value -1, stop value 1, and then we defined the time axis, and then we just wrote the equation. Okay. And then output will be same. We have to write sampling frequency, let's say 1000, amplitude 2, and frequency 10. So it will generate a sine. Okay. So sinc function using the, it will generate a sinc function, sinc using the sinc command. Before we generated a sinc function using the equation. Okay. Here I used sinc command. Okay. Then lab number 3 is just a simple function like this. If I show you here, this. So the question is that using Mathscript to plot step equals to 0.01, plot this equation. Okay. So what is my first step? To define the time scale. T equals starting from 0, then step is here up till 0 is the start value, 5 is the final value, and step is this. After that, then I will define this function, and then I will put this function inside box. Now I will see from here that what is the input? Only f is the input, frequency, and then output t and y. And then we will plot the graph. Let's go to Labview and see. So we define the scale, then we wrote the equation, and then only one unknown, which is f, which will be the input, and output this. So if you go here, we just give the frequency, let's say 7, and then run it. So you see, this is a decaying exponential. Okay. Then if you see here, we can implement this kind of equations which we did in lab 0, that x plus y plus z using Mathscript. How we will do it? We will just write w equals to x plus y multiplied by z. Yes, this is multiplied. So x plus y multiplied by z. So inputs are x, y, and z, and output is w. So if you go to Labview, we just make it like this, and then we will go to panel, and then we will just write here values for any random values I'm writing at the moment, and 9, and we we run it and we get the answer here. Okay. Then this is the same function, same. Here in this question, we generated two different signals using one single Mathscript. If you go here, okay. So for that, we will same way we will define the delta t, then start value, then step, and then stop. After that, the first signal is this x equals to a sine of 2 pi ft. This for the second signal we have to define scale again, 0, 0.5 up to 2 pi, and then this is the output. This is the signal of graph signal 2 equation. Then we will just take one input, second input, then t1 second signal and y second signal. So if we go here, we will just put 7 to conceive 1000. These are the random numbers. And amplitude, let's say 5, and variable, let's say 9. Just run it. So you see, you plotted 2. So this is cosine, and this is sine because it starts from 0. Cosine starts from 90. So here we have cosine and here we have sine. So we got the two signals using single Mathscript. Then here also one more thing is that you have to write your names. So how you write your name? Double click and you can write X, Y, Z and ID. Okay. So this is important. Both sides you can just double click, write your name. Okay. So this is important. Next is again plotting a sine wave. So I have already told you about it. So you just define start value, then you define step, and then stop value, and then you write the equation. And then you go here, you just write the sampling frequency 1000 samples. Sine wave is plotted. So this is it about lab number 2. So okay.